Alright guys, what's up? This video is going to be all about volume of prisms. And so we will be going over different types of how to find the volume of prisms, of what looks like rectangular prisms. We will also cover triangular prisms. We will cover hexagonal prisms as well as some cylinders. So just to give you an idea of what types of prisms I'll be doing in this video. But before we begin, you got to kind of remind yourself of what volume is. So the whole idea around volume, it usually involves 3D shapes. So as you can see, all these images, all these solids, all these figures that we're looking at, they're all three-dimensional. And so if you look at this, for example, the idea of volume is to fill up the space inside of a 3D object. So if I want to fill this up, you can think of liquid, right? I take like water or a bucket, and I'm filling up this box, this prism, from the bottom all the way up to the top until it hits the brim, the top, right, without spilling over. That would be finding the volume of this. And when we talk about prisms, right, these are all prisms because they all have two bases, and they also have rectangles or lateral areas. And so I can kind of talk about what that is first. When I use the word base, I'm talking about the bottom and the top of the prism. So that would be like those rectangles that I just highlighted. We can also look at this triangular prism. So the base is here, the bottom is this triangle right here, and the top of it is this as well. And then I can even go look at this cylinder is a nice one, right? Because it reminds us of like a can of some kind of food or vegetables, or you could even think of a soda can. This is the bottom of the can. This is the top, right? So those are the bases every time I use the word bases. And then the other thing to mention is also when I talk about the sides, we'll be talking about height a lot, which is involved in volume. So the height is always going to be, how tall is the prism? So for example, here, if the height here is 8, the same height goes all the way around on what I just drew. That's 8, that's 8, this is 8, that's 8. Looking at the problem over here, how tall is this prism? The height of it is 6 centimeters. And so let's jump into the basic formula that we'll be using for all volumes of prisms, which is going to be V is for volume. So you're always going to need the area of a base. And the reason I'm saying a base is because, say back here, right? Notice that there's two bases. I only need one of them, okay? When you are talking about volume. So it's going to be area of a base, put that in parentheses, times the height of the prism. You know what a prism is? This is a prism, and I talked about how we need to pay attention to the height of a prism. There will be some times where the height is a little bit trickier to visualize. For example, we can look at, actually, yeah, this is a good one right here. See how this has two bases that are triangles, but the shape is kind of shifted to the left. Technically, the height of it, if I laid it out flat, like if I laid out this triangle flat as the bottom, this is how tall the entire prism would be. That's a little harder to see because we get used to seeing height as up and down a lot of the time, but sometimes they'll trick you and kind of like rotate what a whole prism looks like, but you won't have to deal with that most of the time. So let's go ahead and get started. We're going to talk about going over rectangular prisms first. So this is called a rectangular prism. And the reason it's called a rectangular prism, right, that word rectangle, is because the bases are literally rectangles. And so let's use that formula. So I need the area of a base, and I need the height of the prism. Writing that a little bit sloppy, but the height of the prism is something you could usually find right away for yourself just by looking. And so we can look at this and see that the height is 8 kilometers. So I'm just going to write that here for later, okay? But now I can focus on finding the area of a base. So I'm gonna just take the bottom one. That's what I like to do. It doesn't matter, you can take the top one as well. So I'll take the bottom right here. What I like to do, if I have the time, is like I'll highlight it to remember what I'm using, and then I draw it out again for myself. So I just drew out that bottom, and it looks like I need to pay attention to the length and the width here. So that's 7, and this is 4. Remember that you need area. Area just requires you to do length times width when it's a rectangle or a square, specifically those shapes. Whoa, that was weird. Okay, so let's go ahead and multiply these two. That is 28. So the area of this base is 28. I can put that in right over here. And all that's left to do is for me to multiply the two. And so the volume of this entire prism, if I were to fill it up with liquid all the way, right, let's go ahead and plug that in. It's going to be 28 times 8, 224. Do not forget the units in all of these problems. So it's in kilometers. And when we talk about volume, it is always in cubic units. You might hear the word cubed in there, which is to the power of 3. So also write your little cubed symbol right there, always for volume. So that's how you do that problem. I'm going to go over one more before we move on to triangular prisms. So maybe I'll tackle this one right here. And if you want to pause it and try it on your own and then check how I do it afterwards, you can do that. It's good practice. But I'm going to go ahead and get started. So first thing is remind myself that I'm finding volume. So area of base times the height of the prism. Okay, right away I told you maybe look for the height first. So you're looking at this whole 3D shape. It looks like the height here is 8, right? How tall it is 8. So I'm going to go ahead and just write that in already. So 8 inches is the height. Cool. Now I just have to worry about finding the area of one of the bases. I'm going to go ahead and highlight the bottom one for myself. Cool. And it looks like the dimensions are 12 and 11. And if it helps, right, like I said, draw it out for yourself one more time. So we got 12 and we got 11. To find area, you multiply the two. And so the area of that flat surface, whoa, is going to be 132. And so I'm going to bring that up here. And all that's left is to multiply the two together. So 132 times 8. The volume of the whole prism, if I filled that up with some liquid, is 1,056 inches, that measurement, and it's always cubed. All right, you can look at that for a second, but now I'm going to move on. So we're done with rectangular prisms. Now we're going to move on to these kind of looking like blocks of cheese. I would say is where you usually see this the most. But let's go ahead and maybe start with this one right here. And so I'm going to go ahead and name it. This is a triangular prism. And remember that the beginning of the name is kind of telling you why it's called a triangular prism. It is because the bases, so the bottom and the top, are that shape. So we're dealing now with triangles. Did the formula change? It did not. So it's still going to be area of a base times the height of the base. Oh, not the base, the prism. My fault. Cool. All right, first thing, let's find that height. So this thing's already standing up pretty nice. You could tell that this is the bottom. You could tell that this is the top. So I just want to find the up-down height. And so that looks like it is 9. So 9 here, 9 here, 9 here in the background, 9 inches tall. I'm going to go ahead and just write that in because I'll need it later. So now I can focus on area of the base. So I'm going to go ahead and highlight one of the bases. I'll just highlight this bottom right here. All right. And so I'm going to redraw it. And then we're going to talk about something really quick. So this drawing is all right. What's different this time, right? Is it still a rectangle No, right? We are now dealing with the triangle. I need the area of the triangle. And this is where you should pause and remember that finding the area of a triangle is different from finding it from earlier when we were dealing with the rectangle. And so to remind us, I'm gonna write over here, the area of a triangle is always going to be the base of the triangle times the height of the triangle, right? Don't get confused. Don't get this height confused with this height, right? This is height of the prism, but this triangle itself has its own height because I just want the surface. It's like, how tall is the bottom, right? This flat part. And then it's all divided by 2. And so now I'm gonna look back at this triangle and see what they gave me, right? They gave me the base of the triangle, which is 11. So I'll write that in again. So I got the base. I'm gonna label that B for the base of the triangle. And then it looks like they also gave me the height of the triangle, which is 8.2. So I'm gonna do the same thing here. I'm gonna draw that out, draw a little arrow, and I'm gonna say that's 8.2, that inches, and then that's the height of the triangle. And now we could find the area of that surface, all right, which we need for our volume. So we're gonna take 8.2 times 11. The order doesn't matter. It could be 8.2 times 11 or 11 times 8.2, and then all divided by 2. So let's put that in our calculators. 8.2 times 11 divided by 2. All right. So the area is 45.1. Cool. What you just found was the area of a base. And so now I can plug it in here. So 45. Actually, let me write that a little closer. Let me move some of this stuff really quick. And that works. All right. So 45.1. This is all for volume. I could find the total volume now and just multiply that base, area of the base, and the height of the prism. 45.1 times 9. Your final answer, if I filled it up with water, 405.9 inches. Volume is always cubed. All right, cool. So go ahead and look at that for a second. Remember how different this problem is because we're now dealing with the base of a triangle, right? It required a little bit more, a couple more steps on our calculator of calculating, but straightforward. I'm gonna go to the next page here, still looking at a triangular prism. I'm gonna look at this one here because it can be confusing for some people. So, still a triangular prism. I'm gonna go ahead and highlight one of the bases. And I'm gonna go ahead and highlight actually this one that's more in the background right here. All right. And what's weird for most people when they look at this is kind of like, why are these look like they're on the left and the right and they don't look like it's the bottom and the top? And it's because this shape, they kind of shift. It's kind of like, imagine it was standing up and then they took it and then they shifted it on its flat side. Okay. So real quick, we're finding volume. We need the area of a base, and we need the height of the prism. All right, first thing, find the height of the prism. For a second, you might think that 4 is the height of the entire prism. But remember, these two triangles represent the bases, so the bottom and the top. So maybe I can draw it like this, right? If I drew, if I drew the bottom, and then now I'm going up the height, and then, here is the top of this thing. Not the best drawing. The height should be from one triangle to the other, okay? From one base to the other base, right? So notice how one base is here, the other one's here. So let's go to the tip of this triangle here, right? The tip right here, and we're going all the way to the other one. That is going to be the height. So in reality, though 4 might look like it, it's actually going to be 9, right? Height of a prism is from base to other base, right? That might help out a little bit. So always think about it that way. I'm going to erase this bad drawing, and I'm going to focus back on finding volume. So height of the prism in reality, right? It is 9 yards here. So I'm gonna plug that in because I'm gonna use it later. Got my 9 yards. And I'm gonna just focus on finding the area of this base of this triangle now. And so I could just redraw it like this. And I got that little right angle there. The hypotenuse is 5 yards. I don't really need that. Remember, I just need the base and the height. If anything, this triangle helps me more than the one I highlighted. Maybe I should have highlighted this one. That's okay. So the height of the triangle is 4. I'm gonna get rid of the hypotenuse because I don't need it. And then the base of it, the base is 3 yards. And so remember, area of a triangle is base times height divided by 2. So 4 times 3 is 12. Half of 12 is 6. So the area of this whole thing, oh my gosh, is 6. And I'm gonna plug that in right over here. Got 6. Last step, multiply the 2. 54 yards cubed is filling up the whole prism. All right, cool. Finished with that. Gonna move on now to, we got hexagonal prisms, and then we'll finish off with cylinders, all right? So let's look at this first one. Okay, this is what looks like a hexagonal prism. These might be a little scarier to look at first because it requires more work. It requires more calculation, but I promise that it's not that bad. And if you're worried about having to find the area of a hexagon or any other polygons like, say, a pentagon, a heptagon, things of that nature, then I would say go back to one of my videos called Area of Polygons, because we did cover that about a couple units ago. And being really strong in finding the area of one of those shapes first is really essential for you to then to not struggle with finding volume of the prism version of it. But I'm going to go ahead and move forward with this. So we have a hexagonal prism, area of base. All right, I'm going to keep repeating that. Height of prism. All right, cool. Let's identify or find the height. So from this top hexagon to the bottom one, looks like it's 7 miles in height. We'll keep that for later. Cool. Now let's focus on finding the area of the base. What would be really helpful is to for sure draw out one of the hexagons. I'm going to go ahead and highlight maybe, yeah, let's highlight the bottom one. The bottom one is pretty nice. All right, cool. So you can kind of notice which one I'm finding the area for. And so I'm going to draw it like this. Not the best, but that's a hexagon. They give me some information, right? There's a center. They also give me, notice that if this base is 12 here, right? This is a regular polygon, so if this is 12, all the sides are each 12 all around. The same would go for the bottom one that I highlighted. So they all have a measurement of 12. So I'm gonna draw the center. Remember, to find area of a polygon, we cut it into triangles, but you can just focus on one for now. And I just said that the base of this is 12. And then we need that little height there, right? Because we're gonna have to find the area of this mini triangle first, AKA the apothem in a polygon. And they do give us that, it's 10.4. So I'm gonna draw that. The height of that is 10.4. And so the first thing I'm gonna do is find the area of this little triangle. And then I'm gonna multiply it by 6 because it's a hexagon and I don't just have one triangle here. I have 6 total triangles. And my goal here is to find the whole area. So that means 6 triangles. But let's focus on the first one. So here's the essential, this is basically the height of the little triangle and the base. Take these two and then divide it by 2. So I'm gonna do that on my calculator. 12 times 10.4 divided by 2. So it looks like the area of this triangle is 62.4. Am I finished? No, because I need to multiply that by the rest of the triangles. So I have 6 total, so I'm gonna do this times 6. 62.4 times 6, that is 374.4. This number is the area of the entire base, which is awesome because that's exactly what I needed, right? I needed that up here. And so what's the number I wrote again? I said 374.4. Then now I can find the volume. Let's switch colors. So multiply the two, 374.4 area of that hexagon times the height, which is 7. So our total volume, if I filled that up with liquid, 2620.8 miles cubed. All finished with that. All right. Sometimes you will have situations where they do not give you the height, and maybe they do give you the base, maybe even looking at this triangle. And remember that you can always find the central angle here and then do trigonometry, or you could even do a 30, 60, 90. And this is why I'm saying maybe go back to looking at the video of area of polygons to get a refresher, or even area of polygons or 30, 60, 90 triangles, right triangles. I will not go over this example here. What I want to do is actually, I'll leave it right here, right? And you could try that out. And then let me know if you'd like to see a key for it. But I am going to move on to our final prism of the video, which is a cylinder. And so cylinders will be different. We will still go through the same formula. So let's start with one that's standing up. Yeah, let's go ahead and look at this one right here. So volume is always the area of a base, as in 1 times the height of the prism. All right, cool. All right, new thing, right? We have a cylinder. It's not called a circular prism for some reason. It's a cylinder. But it does still have two bases. They are circles. Here's the bottom. Here's the top. And then here's how tall this can is, right? It's 6 inches. So I can actually already use that for later. I guess I'll write the 6 inches there. And then I need to find the area of the base. So another refresher, right? Having to remember how to now find the area of a circle. And so my reminder is going to be, let's make it over here. Area of circle is always going to be pi r squared. Sorry, doing something really quick. Yeah, okay, cool. And so pi, remember, you can either use this in your calculator as the symbol, or we like to use 3.14. And then r is going to represent your radius. So remember, in a circle, sometimes it'll give you the radius, which is half the distance of the circle from one end to the other, right? So this is halfway. So they do give us the radius here, it's 8. But there will be times when they give you the full line across from one end to the other. That's a diameter. And remember that diameter could always be cut in half to get your radius, okay? But you won't need radius for this. And so this is pi radius squared times the height that I already know. And so I know pi is pi, or 3.14. My radius is 8 squared, which is 8 times 8. So that's 64. And then I have 6 from earlier from the height. And so you can leave this in pi form or fully done. So I'm going to write it in pi form first. What I mean by that is I'm going to set aside the pi, and I'm only going to multiply these two. So 64 times 6. And so I can say that the volume is 384, and then I could bring the pi back next to it like this, and I can say, okay, 384 pi. Or you can also just type in 384 pi on your calculator, basically this, hit enter, and then you'll get a decimal answer, and it'll be around 1206. I'm gonna round it to the, let's do the tenths. It's gonna be 1206.4, and both of these still require the units. The units are inches cubed, inches cubed. And so that's how you do that. The only thing that's different about cylinders, like I said, is remembering the area of a circle, right? Remembering how to find the area of that base. But every single time we've been doing volume, right, it's just area of the base and the height, area of the base and the height of the prism. Let's finish off by doing this last example. Maybe you want to pause and try it out, but I need area of base. You might be tired of me writing that a ton of times, but it helps. Height of prism. I know the height of the prism. This one's easier. Standing up straight. Looks like it's 10 feet. I'll use that later. And then I'm dealing with a cylinder, so that's a circle, which is pi r squared. Do I know r right away? I do not, right? Remember, when the line goes from one end to the other across the middle, that is the diameter. It looks like our diameter is 20. I need the radius. Radius is always half of the diameter. So half of this, you can just take 20 divided by 2. So in reality, our radius is 10 feet. And then now I could use that in here. So here's pi, I'm gonna keep it by itself. Radius is 10, we're squaring it. And I'm also multiplying by 10, which is the height of the cylinder. So that's pi, this is 100. Here is 10 again. I can multiply the 2. We're finding volume. That is 1,000 pi, if you want to leave it in pi form, or you can hit enter. And volume is also 3141. I'll write it with three spaces, 593. It's in feet cubed. It's in feet cubed. Either response is fine, but you found the volume. Okay, I hope that was enough examples for y'all. Please let me know if you'd like another video or if you'd like a link to more practice problems. But this is the gist of how you do volume of prisms, right? I hope that was helpful.